In order to start working with dynamic memory, we need to understand how the program's memory is organized. When we run a program, it's allocated space in RAM, and that memory is organized into different areas, as we've shown visually here. We have an area where our code is loaded. So when the project loads up, your program instructions are loaded into memory for the CPU to execute. We also have a location called the stack. The stack is used to store frames, which represent the functions and procedures that are executing. When you call a functional procedure, it gets added to the top of the stack, like a stack of books. Then if you call another functional procedure, it goes on top of that, as if you are stacking books one on top of each other on a table. When they end, you pop the values off the top of the stack. So it'd be like taking the book off the top of the stack and removing it. And then you go back to the previous book. Then you take that off, and you go back to the previous one. The values on the stack have to have fixed size in order to determine how big that stack frame is. This is why all of the variables that we've been using have actually got a fixed size themselves, with the exception of the vector, which is doing things in the background in order to enable us to have dynamic memory, which is what we're going to look at doing ourselves. Now, the new area that we've really got to work with is the heap. The heap is much larger than the stack. It's much larger than the code area, and your globals will be empty, so that's non-existent. But the heap itself is a large area where we can store lots and lots of data. But it's not accessible within variables in your program. The variables in our program aren't on the heap. The variables in our program are in the stack. The heap itself is used to store any kind of dynamically allocated memory. So you have to explicitly ask for some memory from the heap. Operating system, can I please have 2 megabytes of RAM? And it will give you a 2 megabyte contiguous block of data to access in memory. You can then read and write from that as you want. Now the key bit with the heap is that you are responsible for all of the space allocated on the heap. You can ask for space by calling a function or procedure to allocate you that space, depending on the language. When you've finished with it, you've got to remember to free the space, to say, operating system, you know what, I've finished with that bit of memory you gave me, you can have it back. If you don't do that, it doesn't get given back and can't be used for anything else until you have actually finished. But the challenge is, the thing we need to focus on first, how do we get from the code inside our instructions? So we might have instructions in our codes, this is some pseudocode here, which we can interact with variables that we create. And these variables exist on the stack. And that's all we have access to inside here. So how do we get from the stack here up into the heap? What can we use to do that? Let's have a look at that in the next video.